Dear students, this is our first lecture on multiple choice question problems based on organic reaction mechanism. And in this series of multiple choice question problems, we will have mainly advanced multiple choice question problems, which are potential problems for your GATE or NET examination or JAM examination, and you will find that these problems, they are unique in nature, and you may not have came across these problems in any of the books which you have studied till date. So we will start with these problems, and basically in each lecture what we will do is that we will have 5 problems. In the first 5 slides I will only give you the problem and the 4 possible answers to that, and after the 5 problems I will give in the sixth slide the answers to these 5 problems. I'm not giving answers in the 5 slides because I would like that first you try to attempt these problems yourself and then go through the answers, and then how these answers have been achieved, that what is the mechanism through which this organic reaction has taken place, and why out of these 4 the correct answer has been achieved. So we will start with the first problem. First problem is based on this fumarate Diels-Alder adduct, which is acting as a substrate, which itself has been formed from the Diels-Alder reaction of malic anhydride and this type of sulfoxide. This will act as dienophile, whereas this part will act as die. So, Pimmer Diels-Alder adduct, which has been formed through this Diels-Alder reaction, will act as substrate for this problem, and this adduct on reaction with paratoluene sulfonic acid in THFS solvent at normal temperature, that is 25 degrees centigrade, will give us any of the product which we have shown as A, B, C, and D products. So basically you will see in these problems that most of the reactions they will take place with very common reagents, either acids or bases, or even sometimes some oxidation or reduction reactions. So basically this first problem is an acid catalyzed reaction, which will give us any of these 4 products from this fumarate Diels-Alder adduct. Then second problem is based on dihydrocinolines. These types of structures, they are called as dihydrocinolines, and these on reaction with potassium cyanide, where cyanide ion will act as a nucleophile in presence of aqueous DMF, dimethyl formamide as the solvent, in presence of water. So aqueous DMF will act as solvent. This will give us any of these 4 products. So these out of these 4 products, either we can have dihydrocinolene derivatives as products, or indole derivatives as product, as has been shown in these 4 choices given to you. Then third problem is when oxazolones they react with these types of alkene nitriles in presence of base like triethylamine in dichloromethane as solvent. will give us any of these four products, either A, B, C, or D. So basically, we can have these types of reactions. They come from base catalyzed Michael addition reactions, which will take place to give us the any of these four products. Then fourth problem is based on these types of nitroaryl alcohols. They, in the presence of pyridine and chromic anhydride, using methanol as solvent, can give us any of these four products. And out of these four, only one will be the correct product. And what will be that correct product? We need to know. Then fifth question is, in case of cyclopentanone derivatives having phosphate esters as substituents at the ortho position, they react with dimethyl acetylene dicarboxylate. In presence of these types of trimethylsilyl amine bases, which is a strong base, in presence of tetrahydrofuran THF as the solvent. So we can have any of these four as the product. Either cyclobutene ring will be formed at the cyclopentanone derivative, or a ring expansion can take place to give us 7-membered ring alcohols as the product. So depending upon the reaction of these bases with the substrate, we will get the product. Now, answer to these problems is, in case of first question, the answer is C. In second question, answer is A. In third question, answer is B. In fourth question, answer is C. And in fifth question, answer is A. So now we will discuss one by one that how these answers they have come based on the mechanism of these reactions. In the first case, as you have seen that our answer is C. So here the Pimler Diels-Alder adduct first reacts with one molecule of paratoluene sulfonic acid, and a proton is abstracted from this acid by this epoxide ring, and we will with the help of lone pair of electron present at the neighboring sulfur group, this will create a carbon sulfur double bond, and a positive charge will be created on the sulfur, and this bond will break to abstract this proton, and this will become alcoholic functional. So we will get these types of intermediates. Then these alcoholic intermediates, they will react with another molecule of paratoluene sulfonic acid, and this will abstract proton from here, and OH2 positive will be formed at this place, which will undergo dehydration. Removal of water will take place at this place. Uh, then the tosylate ion generated in any of the these two steps will abstract this proton, which is acidic in nature because of the presence of this carbonyl group, and this will create a carbon-carbon double bond at this place. So you will get this type of intermediate. Then another molecule of tosylate ion generated over here, that will again abstract proton from here to generate the carbon-carbon double bond, and this will also neutralize the positive charge at this sulfur, and this is how we will get our product as this one, which is choice C in the first problem. Then in second problem, answer is A. So here, in case of dihydrocynoline derivatives, cyanide ion will add to the alpha beta unsaturated carbonyl compound moiety present in this dihydrocynoline derivative. So this will add at this beta position, beta unsaturated and unsaturation, and this carbon carbon bond will be shifted to this place, and this will become carbon oxygen single bond, and negative charge will move on to this oxygen, and this negatively charged oxygen will attack the carbonyl group at this place, and this carbon nitrogen bond will break to give us this type of intermediate through cyclization at this place. Basically you can see that the cyanide ion has added to the alpha beta unsaturated ketone part, and then this anion negative charge present on nitrogen will attack this carbon carbon bond, and nitrogen will get attached to this place, whereas this will move to this place, and this nitrogen nitrogen single bond will break to give us a ring expansion intermediate of this type. So this type of anion where negative charge is present on nitrogen will be formed. Then this will attack this carbon nitrogen double bond, and an enolate will be formed like this, with the formation of a new carbon nitrogen bond. So this 8-membered ring will be converted into two 5-membered rings like this. Now in the next step, enolate will regenerate this carbon oxygen double bond, and this will act as a nucleophile to abstract this proton from here to this nitrogen, and this will generate a carbanion at this carbon. Then this carbanion will undergo reorientation. This will create a carbon-carbon double bond at this place to aromatize the ring, and this carbon nitrogen single bond will break, and this will form a carbon nitrogen double bond, and this carbon oxygen double bond will break, and this will create a carbon oxygen double bond, a carbonyl group will be generated. This carbon nitrogen bond will break to create a carbon nitrogen double bond, and this will give this carbon nitrogen single bond will also break. So you can see over here, by breaking of these two bonds, this one and this one, we will generate one molecule of phenyl isocyanate. So this is one molecule of phenyl isocyanate, and then breaking of this bond and this bond will create a molecule of hydrocyanic acid like this. And these phenyl isocyanate and hydrocyanic acid, they will undergo hydrolysis to give us a molecule of carbon dioxide and ammonia in this case, and aniline in this case, and then this will generate an ion of indole, which will take a proton from here, and we will get these types of indole derivatives as the product. So 2-acetyl, 2-acetyl, this is 2-acetyl, this is 1, 2 and 3, 3 cyano, 2-acetyl, 3 cyano indole derivatives, they will be formed as the product, which is choice A in our second. Then third problem answer is B. Here, these types of trifluoromethyl oxazolones, they will react with the base, and this base will abstract this proton present, which is alpha to nitrogen and as well as oxygen, to convert this oxazolone into an enolate ion. Then this enolate ion will act as a nucleophile, and 1 to Michael addition to this carbon carbon double bond will take place, and we will get these types of carbanions as intermediates, and then this carbanion will attack this carbon nitrogen double bond, and this will shift to this place to create a carbon nitrogen double bond by breaking this carbon oxygen single bond, and a carboxylate ion will be generated. Then this will undergo dechlorination and decarboxylation. So this a molecule of carbon dioxide will be removed, and this chlorine will be taken up by triethylamine hydride. So triethyl ammonium chloride will be formed, and a molecule of carbon dioxide will be generated to give us these types of dihydropyrrole derivatives, which will undergo 1,3 hydride shift. So this is 1, this is 2, this is 3. So 1,3 hydride shift. Hydride will be shifted from this carbon 3 to nitrogen 1, and we will get trifluoromethyl biroles as the product. So this is how in problem 3 our choice B will be formed as the product. Then is fourth question, where paranitro-aryl alcohols they react with pyridine and chromic anhydride to give us this is choice C, paranitrobenzaldehyde as the product. The paranitrobenzaldehyde is formed as the product when these two they react to give us this type of chromium 6 oxidant, which oxidizes this primary alcohol to the corresponding aldehyde. And this aldehyde group, because of the presence of methylene group at its alpha position, this can easily undergo enolization to give us these types of enols. So these aldehydes they can be easily converted into these types of enols. Then these enols they further react with one more molecule of chromium 6 oxidant, and addition of these chromium 6 oxidant to these carbon carbon double bond of enols gives us these types of intermediates through delocalization of the charge using this nitro group present on the aryl ring. Then this will again undergo reorientation, and delocalization again will take place to give us these types of cyclic chromate derivatives, where the oxidation state of the chromium will change from 6 to 4. And then through reorientation and removal of this chromium oxidant part, this will be oxidized through hydrolysis to paranitrobenzaldehyde by this rearrangement reaction, and that is how we will get the final product will be paranitrobenzaldehyde. Otherwise, with most of the reagents, only oxidation of this primary alcohol will take place to give us these as the product. But when we are using these two as the oxidants, then a one carbon is eliminated from the substrate, and we will get paranitrobenzaldehydes as the product. Then in fifth example, the cyclopentanone derivatives having phosphate esters at its ortho position, they react with the base trimethyl which will abstract this proton to convert this substrate into an enolate. And this enolate then undergo Michael addition to dimethyl carboxy acetylide, acetylene dicarboxylate, dimethyl acetylene dicarboxylate to undergo Michael addition to give us these types of alene enolates they are formed. And these alene enolates they undergo cyclization at this place to give us a four-membered cyclobutene ring. Then this enolate again undergo reorientation. This will create a carbon oxygen double bond, and this carbon carbon will bond will break, and the ring expansion will take place to convert this 4 membered and 5 membered ring into a 7 membered alpha beta unsaturated ketone group. And this will again neutralize the negative charge present on oxygen through reorientation to give us this type of enolate will be formed, which will abstract proton from this molecule which is formed in the first step to give us these types of enols as the product. So this is how we will get our choice A, that is enols as the product in problem 5. So thank you very much.